Okay, so let's say if we wanted to find the slope of the line y equals 1. Okay, so whenever you have x equals something or y equals something, those are the easiest to graph. Simply because y equals any number is just a horizontal line going through that number. And x equals any number is just a vertical line going through that number. Okay. So y equals 1 is a horizontal line through the number 1. So you have your x and you have your y. Let's say this is your value of 1. Y equals 1 would just be right, well, it's supposed to be a straight line, but as you can see, through 1. If you squint and tilt your head, it's a straight line. Okay, so this is y equals 1. Now, if you want to graph x equals 5, then it would just be a straight up and down line. Okay, so if you notice that when x equals -1, bless you, y equals 1. When x equals 0, y equals 1. When x equals 1, y equals 1. When x equals 2, y equals 1. Any value of x will still have that y equals 1. So that's why it's just a straight line right through. Okay. Now, whenever you have a straight line, remember the slope tells you how fast it's going up or how fast it's going down. If it's just a straight line, it's not going up, it's not going down, which means the slope is 0. Exactly. So slope equals 0 for y equals any number at all. Oops. Okay, so let's say, for example, we wanted to find the slope of the line x equals 5. Okay, so let's say if you have a graph, you know that x equals 5 is a vertical line through 5. Let's see if I can do better with my vertical line. There we go, that's a little bit better. Okay, so this is your vertical line. So you can kind of think of it as, let's say, when x equals 5, then y can equal 1. Let's say that's your 1, that's your 2, that's your 3. When x equals 5, y is equal to 2. When x is equal to 5, y can be equal to 3, or you can go -1, -2, -3. When x equals any value there, your y is when x is equal to any number, then your y can be any other number because it's just straight up and down. Okay. Now the difference between the slope of y equals some number and the slope of x equals some number is a little bit different. So let's say if you wanted to look for the slope of y2 minus y1 over x2 minus x1. And we can pick any one of those points. They'll all give you the same slope. So let's say we pick these two, just because. So we have our x1, and we have our y1, and we have our x2, and our y2. Like I said, just a random pick of 2 points. Okay, so if we wanted to find the slope between those 2 points, then that would be y2 minus y1 over x2 minus x1. Okay, so 3 minus 2 is 1. 5 minus 5 is 0. So we can see there, because our denominator is 0, it's undefined. Okay, so our slope is undefined for x equals 5. Okay, so really, both of these, no matter what value you pick for y, the slope would be 0. No matter what value you pick for x, the slope would be undefined, which just gives you this general formula. Oh, anybody still writing? Okay. Okay, so in general, the graph of y equals c, where c equals any real number, is a horizontal line through C. And has a slope of 0. Okay, that's any value of y you pick. It'd be y equals 30, y equals 1 billion. It'll have a slope of 0, and it'll just go through 1 billion, left to right. And the graph of x equals c again, c is just a real number, is a vertical line through C and has an undefined slope. Okay, so that's kind of the previous 2 examples set to just a general explanation. All right, any questions on either one of those? Okay. Yep, I already did that one. Okay, so now if you remember, we just did, of course you should remember, it was like 2 minutes ago, y equals mx plus b in this slope-intercept form. Okay, because they gave you a slope, they gave you your y-intercept, so hence the name slope-intercept form. Okay, now what if we have our slope is equal to y2 minus y1 over x2 minus x1, if they give you the 2 points, x1, y1, and x2, y2, which is how we found the slope. We got our 2 points. We made one x1, y1, and one x2, y2, and plugged them in. Okay? But what if they give you just 1 point? That means your slope, instead of y2, it would just be some y, because we don't know what y2 is. Minus y1. Okay, we have our y1 and our x1. We don't have an x2 and y2, because they only gave you 1 point. Okay, so what if we multiply both sides by x minus x1? I'll just finish that up. So if you have m equals y minus y1 over x minus x1, multiply this side by x minus x1, and multiply this side by x minus x1. Okay. Well, these two will actually just cancel each other out. So you end up with y minus y1 equals m times x minus x1. And I'll just switch them over because my little quirk of having my y on the left. Okay. Now this form here, or if you wanted to, you can add y1 to both sides. And this is called your point slope form. Now sometimes if they give you just your slope and 1 point, you can create a slope-intercept form from this. And that's what we're going to do. Okay, so let's say, for example, I wanted to find the equation of the line with slope 2, well, negative 2, that passes through the point negative 1, 5. Say we want to write the equation in slope-intercept form. Remember, that's your y equals mx plus b, and standard form. And remember, standard form is just all your variables on one side. So we'll make that ax plus by equals c. So we know that we are given 1 point and a slope. Since we are given 1 point, remember that's negative 1, 5, and the slope, remember that's just m equals -2. We use the point slope form. Okay, so you can always tell what to use by what they give you. Okay, so we know that the point slope form is y minus y1, or you can use y plus, or y equals y1 plus m times x minus x1. Yep, let me read that up a little bit. Okay. Now we know our -1, 5. The only point they gave us is our x1, y1. Okay, these are our knowns.